Imagine that in 2 or 3 years, many familiar jobs in healthcare, clinical research, and health tech will no longer exist in their current form. Managers will need to work with data, doctors will use analytical tools, and researchers will work with code and models. Hello everyone, and welcome to HealthTech Explorers. Today, I want to show you how I am preparing for this new reality, even without access to real medical data. As we've discussed many times on this channel, mass layoffs in clinical research, health tech, and healthcare management are making many people think about changing or upgrading their profession. I don't believe that in a couple of years the old pure roles will still remain. The future belongs to hybrid specialists. For example, doctors who can also work with data and analytics, clinical trial managers who are also data analysts, quality specialists who understand business intelligence, and regulatory professionals who know data governance and machine learning. Even a regular data analyst will no longer be just an analyst. New responsibilities will be added, while some routine tasks will be taken over by artificial intelligence. I have always had a strong passion for data and artificial intelligence, but I clearly understand the main rule. The quality of your output depends entirely on the quality of your input data. The most powerful algorithm is useless if the original data is poor or inaccurate. That is why we need to start training now. The biggest problem is that real medical and clinical data is almost always strictly confidential, so instead of waiting for access, I decided to start practicing and testing my ideas using synthetic data. That is how the blood bank data generator project was born. This generator creates a quite realistic database for a blood bank. It includes 3,000 donors with demographics, ethnicity, blood group, hemoglobin levels, medical conditions, and eligibility checks. It also generates 10,000 donations with realistic seasonality and day-of-week patterns, collection specialists with different experience levels, including some problematic staff who make more mistakes, collection sites such as permanent centers, mobile units, and periodic drives, sample quality issues like hemolysis, lipemia, empty or insufficient tubes, and mislabeling, laboratory test results with turnaround time calculations, infection screening, antigen phenotyping, and donor questionnaires. Let me show you how it works inside. At the beginning of the file, there is a convenient configuration section. Here, you can quickly change the number of donors, the number of donations, regions, dates, and many other parameters. Then there are separate blocks for generating each table: donors, specialists, donations, sample issues, laboratory results, and so on. Everything is built in a fairly modular way, so it is easy to add or remove parts if needed. Now I will run the generator. And here we go. In just a few seconds, we have a complete database, one big Excel file with all the tables on separate sheets, and individual CSV files for convenience. Right now, I am actively experimenting with analytics on this data. I am comparing donor profiles, calculating specialist error rates, analyzing seasonality, turnaround time, and many other things. In future videos, I will show you what kind of analytics I have already built. In the upcoming projects, I also plan to create a generator for clinical trials data. That will be the next big step. The link to the GitHub repository, where you can find both the Python script and the Jupyter Notebook version, is in the description below this video. If you are also interested in working with medical data and preparing for future hybrid roles, please give this video a like and subscribe to the channel. Write in the comments, which medical areas or types of data would you like to see in the next generators? Clinical trials, hospital data, laboratory results, or something else? I will be happy to read your ideas. Thank you for watching, and see you in the next video.